Okay, we'll get started. So we have 30 plus people to respect everyone's time. So this session is for 1.5 hours team. Uh, I'll just bring my slide deck up. So it will be a combination of slides. But we didn't want to make it a slideware. So we'll actually go onto the FHIR site. I hope I shared the link in the invite. You've been able to browse through that HL7 FHIR website and what it means. But if not, we'll anyway cover the basics. Okay? If you've done, you'll be able to understand this better, faster. Okay? We'll also talk about some use cases and then we'll do some hands-on. So for people who would like to follow us on a hands-on, if you have a FHIR server installed or have access to open FHIR server, please log in. We'll spend last half an hour doing some hands-on. But if not, don't worry. We are recording this session, so you'll have access to this recording even if you want to refer to it later.
Kapil, I think you need to start recording.
Yeah, yeah. Just give me one minute. I'm bringing the slide deck up. Slide deck. Okay. My screen visible?
Yeah,
Yes.
it is.
Okay. How do I start recording? Uh, Is this something you can help me with, Karthik?
It's in more tab.
Don't get at more tab in a sharing mode.
It was beside the camera, sir. Left.
There's no more tab. No? You have to go out of presentation mode and then. Okay. Okay. So let me reshare. Okay. So again, thanks everyone for joining, especially for people in India. It's Friday evening. I know. Want to go back, have a nice, enjoy your weekend. A Friday evening for people in US. Thanks for joining. You may be skipping some of your stand-ups meetings. So I hope you get some good takeaways from this session. As I just mentioned, we'll divide this 1.5 hours into three different sessions. First half an hour, we'll talk about interoperability in general, introduction to FHIR, some of the implementation guides and resources. Will take you through some of the portal resources which are there, which I shared in the email link. For people who may be already working in FHIR, this may be a repeat, so please bear with us. For the next 30 minutes, and the first 30 minutes will be covered by me and Karthik. Next 30 minutes where we'll talk about some of the interesting implementations which are burning, right? Which are hot, pun intended, right? So Harendra, who has been our SME in CVS, now in BCBS, also engaged in Elevance. He'll talk about some of the use cases which are getting implemented. Okay, and so everyone gets a flavor of so why FHIR is important. And then last 30 minutes, Suman will be doing some hands-on with all of us. So she already has a FHIR server installed and have access to open FHIR server. So if you want to follow along with her, please get access to this FHIR server. Happy FHIR server, if you will, but there are around 10 to 12 open FHIR servers, right? And follow along, so it will get you started. So interoperability, what is it? In general, if you were in the town hall day before, Abhishek covered it a bit. So when Affordable Care Act was passed in 2010, right, also called Obamacare Act, they made the healthcare universal. So till that time, say patients were logged in with payers, providers, and the EHR systems. So it was very difficult for a patient to move from one EHR system to another. Just like in India, if you can think of, you had your mobile numbers, you were logged in with the vendor. Okay, it was very difficult to move away, and if you did, you would lose all the history with the previous vendor. So something similar was there in healthcare. But universal healthcare, the administration knew it will mean a lot of additional cost in healthcare. Okay, and the intent was while increasing the healthcare coverage, how does US reduce the cost of healthcare as well, right? In parallel. So the intent was if the coverage was doubled, healthcare cost should not double. So they thought of all this and tried to make it competitive. Right? For example, if I, as a patient, I am not satisfied with my provider, with my HR, I should be able to go to another provider very easily, and all my health records, history should get ported very easily. It was not possible. So that would trigger a competitive spirits in the industry, and as you know, competition breeds efficiency and the costs come down. We have seen this everywhere where it has happened in banking, in telecom in India. So that was the intent back in 2010. Interoperability was already thought of. HL7 organization itself was established in 1987, like almost 38 years ago, right? But the adoption of that was not very prevalent, primarily because of, again, business reasons. All vendors wanted their patients to be logged in, and hence there were healthcare silos. Now, this created a lot of entropy in the healthcare system. Why would, say, I, as a provider or a EHR, want to make my patient data interoperable, which anyone else could use it, right? So hence, first 5 years between 2010, 2015, there was a lot of, not too much of adoption happened while the healthcare coverage became universal, but the interoperability suffered. And then we'll see more regulations came in as the uh, Health and Human Services Department realized, hey, they were not meeting the goals of interoperability and thereby cost of healthcare not coming down. They passed on some rules, regulations, which we'll go through, right, which has now made this interoperability almost mandatory for every provider, every EHR. There are a lot of laws which have been passed, at least in last 10 years or so. Now every patient date can control their data, where it should be stored, where it should not be stored, how they can delete it. And it's all possible because healthcare interoperability standards also developed at the same time. And there have been a lot of standards like X12 in the past. X12 is almost like 50, 60 years old, right? Which was all about exchanging files in a pipe delimited form. So it was not very easily consumable. But then came HL7 V2, V3, which made it easier. And then there were some deficiencies in HL7 V2, V3, and hence CDA, or consolidated clinical document architectures standard came up, which was, I think, way back in 2013 types. Okay. It was a monolith architecture, not very granular, but still allowed portability of data across pairs, between pairs providers. Okay. And post that, FHIR, which means fast healthcare interoperability resources, came up. It got launched in 2017. It's been 8 years, believe me, uh, uh, which made it very easy to implement. It was very granular. Not all the attributes of say patient data needed to be interoperable, right? Only some sections could be. So it allowed scalability, extensibility of this interoperability paradigm. So I've given some resources across the slides. When you get time, please go through them. They're all very interesting blogs, etc. But when we talk about interoperability, these healthcare standards that we see below allow only foundational and structural interoperability, right? It's like I have created resources, I've created a structured data, okay? But how to read the data, understand the data, uh, make it usable, etc., still needs to be implemented, which we call semantic interoperability. In Fireword, this is implemented through FHIR profiles. Okay, and we'll talk a bit more about FHIR profiles. But not just about semantic interoperability when data needs to be exchanged en masse across organizations for, say, population health. Okay. Then FHIR organizations or HL7 consortium has come up with implementation guides. Okay, we'll again talk about what these implementation guides are, for what reasons they should be used, etc. So as I talked about, this has evolved. I've only shown a timeline from 2016 onwards, but this even precedes that. But the big change events happened as we have shown on this timeline. One thing we'll like to call out after 2010, as I talked about in 2020, right, where the patient access final rule came out, right, which were by CMS, which was actually a big trigger, very big trigger for adopting FHIR standards. It almost made it mandatory for every provider payer to exchange data using FHIR. Okay, and not only that, interoperability also meant how to control the privacy and confidentiality of data. It should not be like everyone has access to everything. So while the patient access rule didn't specify any guideline or a protocol for managing consent preferences, we have seen over the last 4 or 5 years, almost every payer, every provider has implemented a layer on top. Some call it consent, some call it preferences, some call it consent preferences, and some of you might already have been working on these projects. So that, along with FHIR, made this whole transformation possible. And now we see patient data can be easily transferred to another payer, obviously with the consent of the patient. Right? The whole premise here, patient owns the data, their own data. So there's a lot more happening at this time, a lot more regulations coming in. We see there's some vendors who still are not very open about implementing interoperability because they want their patients to be logged in with them, but the regulators are coming hard at them. Okay. So I'll give it to Karthik to talk more about FHIR, right, and why FHIR was required, and also take us through the FHIR structure before I give it to Harindra. Karthik, over to you. Karthik, Karthik, are you on? We can't hear you. Okay, looks like some issue on his side. We're still not able to hear you, Karthik. Okay. So meanwhile, Karthik comes online. Let me continue. And Karthik, please interrupt when you can are able to join. FHIR stands for Fast Healthcare Interoperability Resources. So each word in this has a meaning. Fast means this is a protocol. It has to be fast. Data should not be shared in batches, right? The intent here is to be real time. So it is meant to be a lightweight protocol without too heavy attachments or payloads in there when they happen. And there are ways and guidelines which HL7 has come up with on how to keep it lightweight. But there are still some challenges. We are actually in FHIR version V4, which is very widely adopted at this time. but there's also a R5 which is available, and R6 will get released very soon. So FHIR itself is evolving. It's obviously healthcare specific, allows interoperability. It's not just about exchanging standard messages and payloads. It allows the players to extend that the data that they want to share. And we'll see more on how that extensibility is implemented. It's not like there are only 100 attributes and only 100 attributes can be exchanged. There is a way of extending it, right? And these are resources. These are very modular. So today in FHIR version V4, there are around 57 resources, be it a patient resource, be it an observation resource, be it an encounter, be it a claim, etc. Okay, so most of the resources are covered, but these are growing as we speak. Okay, V6 probably will see addition of another 20 resources getting added there. So Karthik, are you back?
I am. Can you guys hear me now?
Yes, we can.
Excellent. All right. So let me reopen the deck and start sharing. Just give me 1 second.
Okay. So we just covered the introducing FHIR slide, so we can start
Okay.
from the next one.
All right. I will do that. The deck. Two.
We just covered
All right.
this.
Yes. So apart from the theory, all right, the best way to start getting acquainted with FHIR is to actually look at it, see a resource, and see what it does. All right. So I'm going to switch to here, and I shall zoom in a little bit so you can see it better.
Meanwhile, if anyone has questions, feel free to put that in the chat. Okay. We'll take a pause, but we'll also try to answer in real time.
Okay. All right. So this is a FHIR resource for the procedure. All right. You're going to find procedures in clinical records. You will find them on claims. They're one of the most basic units of the clinical concept, right? And FHIR resources, for the most part, are notated in JSON. That is, a FHIR resource is nothing but a JSON document. You do have XML as well, but that is not very frequently used. JSON is the most commonly used. There are many technical advantages to using, depicting data in JSON, in a JSON format, right? So to begin with, what is there in a FHIR resource? I'll just pause here for 1 minute for you to take it in. Upfront, it recognizes this is a procedure. There is an identifier for it, which can be used for linking it to other resources as well, right? Then you have a space for a, a human readable text, and you have all the information about the procedure, right? That it is an appendectomy, it has a code, more on that later. It occurred on 2013, April 5th. Some doctor, Cecil surgeon, recorded the procedure. That is, Cecil surgeon was the person who documented it. Cecil surgeon was also the person who did the appendectomy. Why was it done? Right? In this case, it is just a text, but you could have more. There is some follow-up to the procedure. You have a general note, and you have some other external references. Any questions at this point? Okay.
No, Karthik. So let's show on the portal different resources which are available.
Sure. Yep.
So people can understand.
Yeah. I'm just going to very quickly say why we have FHIR and what its advantages are very quickly, right? Let me not bore you with this. As Kapil had already mentioned, it is because we want to, or at least the government wants to make sure that the patient has more control over that data. So imposing a standard on the industry to be able to exchange data quickly, instantaneously, and in a standard format that everybody can understand. You move away from black boxes. And even if you do have black boxes, that is EHRs that are walled in terms of technology and nobody has any access to its internals, think Epic, all right? Even then, your regulation is forcing EHR vendors to expose APIs where FHIR resources can be retrieved and sent to, right? And also, there is a shift towards analytics where we want smaller chunks of data. We also need smaller chunks of data because everybody, the world is moving away from PCs to devices, and everything is moving on to the cloud. So it becomes imperative that we are able to instantaneously exchange small packets of information, as opposed to what used to happen once upon a time, where people would run specifically nightly or weekly jobs exporting and importing data, and then you have another job to consolidate, read, quality check the data, and then integrate it into the system, so on and so forth. We are moving away from that, right? Okay. So what are the advantages of using FHIR? It uses today's standard technologies. It is also flexible enough to adapt to tomorrow's technological innovations. It also um, allows for a certain amount of tailoring. Authentication is built into these things. And although FHIR is in discrete resources, as they call it, you can link them together any which way you want, right? So before I take you to showing you the FHIR resources and everything, it will be useful for you to understand a couple of concepts because of which FHIR is the way it is today, right? So up on top here, you see an HL7 message, all right? And for those of you who are from the RCM EDI world, this format is going to look very familiar to you. When HL7 V2 was released in 1987, initially, they just went ahead and copied the structure of X12 EDI. They did nothing different. A pipe separates the field, the caret here separates the different components within the field, so on and so forth. All right. What I want you to notice is this line here, NK1, where you will see something called SPO, which you will not understand just by reading it, right? And that is because SPO is some sort of code. And in the HL7 world, we had these codes. Everybody needed to understand the structure. It was painful. Then we moved to CDA. This is XML based. And again, you will notice They are using a lot of these code systems, a lot more of them. So this is a diagnosis where they are codifying diabetes as this SNOMED code. And data is hierarchical. Now, it's a clear relationship, right? You with me so far? Any questions?
Okay.
Okay, all right. So the resource, I mean, we keep saying resource, resource, resource. What is a resource? A resource is it's the basic unit, right, of data, depiction of data in the FHIR world. Okay, each of these is each resource type is a healthcare concept. So you have patient resource, you have condition resource, claim resource, so on and so forth, right? And each resource will contain in itself, you have the data itself, you have identifier, and you have metadata. Metadata indicates when it was last updated, when it was created, what is the status, so on and so forth, right? Let's move on to showing you the FHIR thing itself. Okay. So if you were to go to hl7.org/FHIR, this is what you will see. If I come to data types, because a data type, of course, is the basic the thing. You have primitive data types, of course, which are used within the FHIR resource, decimal, date, time, Boolean, so on and so forth. But you can combine them to create these so-called general purpose data types. And I'll just show you one. Like, okay, so if you realize something like human name, whether you're talking about a diagnosis, whether you're talking about a patient, whether you're talking about an appointment or a claim, you have to give data about people in those resources or in that piece of information. So what they do is they have this structure, right? This data type called a human name. And this unit repeats within resources, right? So you have primitive data types, you have general purpose data types, which are built from it, and many of these get combined into resources. Any questions so far?
I do. So what happens when those data types are not inputted by the end user?
In the sense, I didn't understand your question.
So the data types
Mm-hmm.
that you're referring to,
Right.
in most cases of a failure, right?
Mm-hmm.
How does FHIR handle those misinputted data types?
Okay, all right. Let's come back to this resource over here.
Let me
Right.
take that quickly.
Mm-hmm.
See, FHIR is a protocol. Okay, it allows data to be exchanged between two parties. If data is not there, obviously the data will not go through. So it won't. You will not find too many errors. Just like in telecom, right? Your network packages, whether it's a noise or a voice, the packages still go through. So similarly, FHIR will make sure all the data which was available, which were mapped, goes through. So on top of this, there will be user interfaces like your patient portals, your HR UIs, and they would be required to map their UI attributes onto this protocol. Did I answer your question, Aaron?
It does, but how do you error out, or does FHIR error out? And then how do
No,
we fix that?
okay. FHIR itself will not error out. It is your implementation of FHIR, and you can choose to decide what to error out or not. Let me give you an example here. I'm coming back to this procedure, all right? You have the status of completed, all right? Which means that this procedure is done, all right? This information is about a procedure that is done, all right? Now, because this is a JSON object, I can choose to drop this altogether, all right? And like Kapil had said, the transaction will go through for sure, all right? Somebody is sending you the data, you will certainly receive it. Your system will receive it. Your system will be able to parse it. But in your implementation, in your system, if you choose to say that unless a status is mentioned, I will not accept this piece of data, it's up to you. It's your choice. If you implement it that way, it's fine. Or you can say if that information doesn't exist, I'm going to assume that it is completed. If it doesn't exist, I'm going to leave it blank because, hey, whichever is the database into which this information is supposed to go to ultimately, this field is not mandatory. It's optional. So I'm
Right,
fine.
but if SNOMED or LINK codes aren't
Mhm.
compatible between the two systems, how does it
Right.
handle that?
FHIR does not. Okay, FHIR standard. Okay, I was going to touch upon that later, but since you brought up this question, all right. Um, FHIR only recommends that certain vocabularies be used. It does not mandate it. All right. So over here, it like I'm highlighting, when they have chosen to put a SNOMED code for the appendectomy. It could be CPT4. It could be a HCPCS2 code, right? It could be ICD-10 PCS as well. That's fine. I mean, that's one of the pitfalls ultimately of um, interoperability, because you have so many overlapping vocabularies, right? Now, FHIR recommends that in certain resources for certain nodes, you use certain vocabularies, but it does not mandate it. So if for instance, you're expecting CPT4 and you end up with a SNOMED coming in, well, you just have to handle it.
So I think, let me add to this. There's a
Yeah.
concept of cardinality in FHIR data model. So you can have like 0 to 1, 1 to 1, 1 to many kind of relationships. So which means each of these resource we are seeing uh, is supposed to follow that cardinality, which determines whether this resource is usable or no. It's not to not pass through the data, but it's a message to the receiver that this resource is usable, consumable or no. I think that's an advanced concept. As maybe that's a level 2 session of FHIR. We can go into that. Uh, Okay. So Karthik, let's go
Okay.
through the FHIR
Let's.
resources, right? And what are
Sure.
those cardinalities, codability, etc. I think that will
Yep.
make the concept clearer.
Correct. Okay. Okay. Let's just go back to this. Um, Let me go back. Let me start with this. The patient, as we do always. Hello, world. Right. Now, you start, the first thing that happens is this, it says normative. Normative just means that the HL7 committee has voted on this to be final, right? That's all it means. It's a domain type resource, right? You get, of course, there is an identifier to it, a patient identifier, and the cardinality here is 0 to star, which means that I can send a resource without a patient identifier. I can send a resource with multiple patient identifiers. So for instance, I can, if I want, drop the MRN altogether, or if I want, I can send an MRN. I can send an insurance identifier. I can send an MPI identifier, master patient index identifier. Yeah, I can send all three. All right. So that is that. Now, going down.
So just on the previous question. So since it is zero too many, you may or may not send, but if it was one too many, then you will definitely need this identifier to be there. So there are some attributes in some resources which are mandatory. Okay, that's how cardinality determines whether this resource is usable or. Yeah, Karthik.
All right. Okay. The data type over here, if you notice for identifier, it says that it is an identifier data type. All right. The identifier data type itself is made up of these fields. Sorry, these nodes. It starts with the, of course, identifier in the JSON structure. It's the use, um, usual, official, temporary, secondary, old, whatever. It could be one of these. It's okay. It has a binding of identifier use, which means that there is something known as a value set. There is a range of values that ought to be in this field. However, again, going back to what Kapil had said, it's supposed to be usual, official, temp, secondary, old. However, as Kapil had earlier said, if you send something else in there, if you send a code of A, B, C, D, E, F, G, um, FHIR itself is not going to reject it. It's a sending and or receiving systems that have to deal with it, right? So an identifier could have a type. So you have identifier type codes, um, which system it came from, what is the value of the identifier itself, and when this thing identifier was valid for. So in the case of something like an insurance identifier, maybe it is only valid for the time that that person had coverage. So if it's a slightly older record, you could say that this is the insurance identifier, and the period, the time period within which it was valid was 2023 Jan 1st through 2023 September 30th, right? Okay. Coming back to my patient resource. Mm, let's move on. Marital status. You can put attachments in FHIR resources. You have a data type of attachment. So you can include binary data. Wherever necessary, it's there, right? You have the patient's contact information, communication language, so on and so forth. So this shows what a resource is, or what information ought to be in a resource. More importantly, over here, you've way at the bottom, you've got something known as a link, right? So you can link this patient to other resources. Right? Okay.
Okay. So I think, Karthik, in the interest of time,
Mhm.
let's show the value sets and
Yep.
let's see in practice how it is implemented, which Harendra is planning to cover.
Okay. Okay. You have vocabularies or terminologies, SNOMED, RX norm, HCPCS CPT, ICD-10, LOINC, so on and so forth, industry standard codes. You also have value sets. Now, what I showed you just now, let's just come to, let's go to the procedure resource, right? It is recommended that you use SNOMED CT over here, all right? But at the same time, when we went to, for instance, to the patient resource, and we saw marital status, and you had marital status codes like this: annulled, divorced, legally separated, so on and so forth. Now, this is not an industry standard terminology, but it is a set of codes. Therefore, that becomes a value set. You also could have value sets which are combinations of different vocabularies, right? And every situation, again, when you get into implementation, you should figure it out. Uh, every scenario, every situation will choose to combine or use certain parts of the terminology. Like, for instance, you could use bits of a few SNOMED codes and a few ICD-10 codes to denote a particular disease. And that is because your system can handle both SNOMED and or ICD-10. And that becomes a value set, right? They are specifically defined for certain clinical or administrative purposes. Any questions here? And finally, when you want to get or work with FHIR resources, every FHIR resource, whichever is the API that exposes FHIR resources, you have a URI to query the resource, and this is what it looks like. You get a standard URL with a resource type, with a resource ID or a resource type, and various query parameters on top of it.
Okay, so anything else you have after this?
No, I think if there are no more questions, we can hand it off to Karendra now.
Okay. The team, feel free to put your questions on the chat. We'll try to take it in between as we go along. Harendra?
Yeah, let me share my screen. So I will talk about the, I'll start with the implementation guides, which are the building blocks before we go into any implementation, and go and then walk over some of the use cases that we have implemented at multiple for peer clients. So what are implementation guides? So we talked of resources. There are like 100 plus resources currently in the FHIR versions. Talked of the structure of these resources. But when, and we talked of profiles, I think briefly. So implementation guides is built upon these base FHIR resources, R4, which is the current version in use. and you can understand this as a recipe. So you have the ingredients, which are the resources, but to build, like to cook a dish, you need the recipe, how these resources are going to be used. And each geography, like for US, there is a when you go to fill a patient's demographics, there's requirement to capture race and ethnicity. So race and ethnicity is a very US specific requirement, and it is not captured in the FHIR R4 resources. So for this, we have implementation guide, and US core is one of the most important implementation guides. I'll switch to to show you how the US core profile looks like.
All
So
right,
you
so
saw,
let's do a use case scenario. I came in with appendicitis. How do you handle it? Or how does FHIR handle it?
yeah, sure. I'll cover the use case. But before that, I just want to walk you through what, like you saw the resources, but what extra things, what are the mandatory and the constraints that are provided by a implementation guide. And you see this mandatory and must support elements. So this is absent in a FHIR R4 resource. So here they say each patient must have a patient identifier and a patient name, and it must support a birth date and an address. So these are mandatory. You cannot create a patient resource without the patient identifier or a medical record number or a patient name. And if you have the date of birth and address, then you must provide these elements. Okay. So you see
Right,
this
but a
structure.
homeless guy comes in or they're involved in a car wreck and they can't know their own birth date or name. How do you handle it? So
Yeah,
you just reject it?
yeah. So in this case, in the exceptional scenarios, there is a provision to create an empty data element, and there is an extension. That's how extensions come into picture. So during actual implementation, if say we do not have a mandatory element, we create an extension to that field and provide the reason we cannot have that field. So you have to provide that reason, that for this reason, because the person, it could be an emergency case and you have to create a patient resource, and you don't know, you can assign an MRN, but you don't know the name of the patient. So in this case, you have to provide the reason for not getting this information. So this is a structure of a profile. You see the patient resource, and then you see the patient profile. You see these extensions have been added in US core to capture race, ethnicity, tribal affiliation, and other elements. And you see that there is a S, right? That was absent in a resource. So S means that this element must be supported. You have the information, and if not, like in case of identifier, it is a mandatory also. Okay, so this element is a mandatory as well as a must support. Some elements you will see they are optional as per the FHIR R4 specification. They are optional, but US core says that they must be supported. So this is the difference between a resource and a profile. Let me switch back to the presentation. So on the right side of the slide, you see the multiple implementation guides that are listed. The US core, it defines the set of standards, which is based on the US CDI, which is United States Core Data Interoperability Standards. It is mandated by the federal government. There is a Karen profiles, and Karen is something if you need to exchange claim related information. like explanation of benefits or claim. Then Karen implementation guide is used. For medications and pharmacy data, there is a formulary implementation guide. For exchanging clinical data between providers and payers, there is CDEX, which is Clinical Data Exchange. Similarly, between if two payers or two health insurance organization, if they need to exchange data, they can use a payer to payer data exchange, which is PDEX. Now, the last one I will talk in one of the use cases is to support electronic prior authorization. These you don't have to go into the uh, specification, but these are a bunch of implementation guides. They concern about the coverage requirements, getting documentation and prior authorization support. And these are all mandated as per the recent, I mean, it came in last year, but there is a CMS mandate to have electronic prior authorization across payers in United States. So now we talked about implementation guides, and in actual healthcare setting, how these resources and like the US core and the different implementation guide we talked of are actually implemented. Say, so this I will talk about patient life cycle. So it starts with when a patient schedules a doctor appointment. So in that case, there is an appointment resource uh, and there is a schedule resource. So schedule is the date and time of your appointment. It captures the insurance and other information that you provide during an appointment booking. And when the patient visits the doctor, uh, then you have to provide the doctor has a practitioner resource. So in case of a US core, in every practitioner in US has a NPI or a national provider identifier. So that is a must support element in a practitioner resource. Similarly, for a patient, you have to provide insurance and other like a driving license or a personal identification. And you have to provide the coverage information, what health insurance that you have. And during this patient encounter, there could be multiple like vitals have to be collected. There you have to uh, uh, enter some forms about family history. If you have like a history of any disease, chronic disease or allergies, the doctor can order blood test or any diagnosis related information. So that are captured in a condition or a diagnostic report, which is kind of a report, lab report, and a service request. Service request is for orders, like a lab orders could be a service request. And when the doctor prescribes your medications, your prescriptions, they go into a medication request. And when you go to the pharmacy and actually get those medication, that becomes a medication dispense resource. All these resources, they capture the data during the entire your healthcare visit life cycle. Right? So the encounter is over, and once the claim is sent from the when the bills, your medical bills you get, so that is a claim resource, and patient get an explanation of benefits that out of $100 that you paid for the visit, 50% was paid by the insurance company and 50 could be your out of pocket expenses. So all these different the FHIR resources that we talked about, how they are actually implemented. So I will talk about a use case, a very common use case we talked about of different resources that we saw during the entire patient life cycle. But where do these resources go? Like you created those data and you created those resources and you have all the data. But what you are going to make use of that data? And there this clinical data repository comes into the picture. So you have data sources on the left side. You have claims, pharmacy, clinical, all your encounter data, all your medications data, all your claims and explanation of benefits, all your health information exchanges. The data from different sources are coming into this process element, which is clinical data harmonization. So harmonization, you can understand of as a translation of data. So there it could be coming in a FHIR as a FHIR implementation guide or a FHIR resource. It could be a non-FHIR. It could be HL7. It could be a CCD. So FHIR harmonization engine, its purpose is to convert all the data into a specific implementation guide format. So for US geography, it is the FHIR US core and other related implementation guides. And everything is stored in a clinical data repository. So this central repository, it stores all the patient's data in FHIR resources. And then you have all the data now. How are you going to use that data uh, for your use case, like for a provider or a payer? How to make good use of that data? So over that data, there is a interoperability healthcare APIs. So when the first of the patient access rules was implemented, we implemented this use case for CVS. So there was there was a Google Cloud Firestore where all the data from all the patients that CVS or Aetna caters to came in that FHIR repository, and we had healthcare APIs built on that, which could do a patient read, search, or if you want to get all patients having diabetes or a particular like a chronic condition, you can easily search on that data using healthcare APIs. And this data was sent into a BigQuery where this was flattened and used for analytics. So here all your AI engines, Gen AI comes into picture, or your analytics use cases can be implemented over that data. And providers and payer, they have different system like utilization management, care management. So all these and patient data viewer. So this repository, it provides a longitudinal picture of a patient's health record. So it's a 360-degree view where you can see the entire history of the patient from different providers. He may be getting services from multiple providers. Maybe he was living for a few years in another state and he moved to a new state. But here in the clinical data repository, you have his entire data and you can run your analytics engine on that. And for population health, using AI, you can then do predictions on that data. So this is an enabler. FHIR is a very, very good enabler for all the analytics and AI purpose. Any questions on this before I move on to the next use case? So
No, looks like you're good.
okay, yeah. So this is for electronic prior authorization. This diagram may look complex. I will just explain the current process. And prior authorization is when a doctor orders a CT scan. Okay. So first, that order has to get authorized from the payer. Right? Is this member covered and is this allowed? And based on the medical necessity, right? You may not need a CT scan. It could be something that the doctor orders, but you never need it, right? So based on your medical necessity, they will check your condition, your previous encounters, your history. And do you like the question on the payer side is, does this patient really need this service or procedure like a CT scan to be performed? And they can deny or authorize that request. So this process currently it is via phone, fax, or some portals are there, but mostly via phone or fax. So when you go to a provider, you have a health insurance card, and on the back of that card there is a number. So they call that number and they said that we need this procedure has to be performed. So they have to send those documentation, like they may need all prior imaging, all prior CT scans that was performed, or your condition diagnosis, all the notes from the payers, from the provider, like your doctor note or clinical notes, your vitals and previous lab results. So all this information is faxed to the payer. Okay, and this process it takes many days. Like if there is a uh, if something that is like say some insulin was ordered and the patient is very critical, like he needs insulin immediately, but this prior authorization they may takes even days or weeks based on the systems that are available on the payer side. So there is actually a nurse who reviews all the documentation and everything. He may like approve or deny, and it also goes for a review. So if something is denied, there is the medical necessity, there is a review from medical director. So this whole process could takes even weeks. Okay, so now CMS has mandated the electronic means using FHIR implementation guides that we talked of, CRD, DTR, and PASS. So that is a mandate that has to be implemented by January 1st, 2027 for all payers. And this mandate is only for government programs like Medicaid and Medicare, but commercial also, like all the payers have pledged to include all commercial plans. Like there was a recent pledge from all payer CEOs that they will, like 80% of all prior authorizations they want to automate. So it's a big lift, like it's billions of dollars of business, and the whole process it has been going on for many years. So that there is a every pair is impacted by this change. So this complexity, you can understand that the provider and the payer, the communication between them, which was earlier via phone or a fax, is now going to be through FHIR APIs. Okay, so all these get post and CDS hook, these are other specifications that are mandated to be used. Okay, so all the communication is going to be electronic in future. There will be APIs on the payer side, and these APIs behind them, there will be orchestration where the data will be converted and then sent to the backend system, which is like a utilization management system or a claim process system where they check the member eligibility, and everything will be automated. And this is a very good use case for AI and analytics, because the process which was being done manually has to be automated, and it could be in real time. So things that were taking days or weeks previously could be done in real time with all the automation and use of FHIR resources and APIs.
Yeah. So just adding on, I think this is a very hot use case, as Harindra mentioned. By 1st January of 2027, within another 1.5 years, there are 10,000 around plans which are implementing electronic prior. And we already have launched this offering. We have quite few very good conversations going on in some of the biggest with some of the biggest players on this. Harindra himself is working on one of those. And anything else you have?
Yeah, so the last one before I hand over to Suman is about the open source FHIR servers. We just listed a few of them, but there are many more, like there are 20, I think 20 around open source FHIR servers. So, and the most widely used are FHIR, which is Java based, and it has open source portal as well. You can connect using those APIs. There's a Firely server, the different cloud implementations like Google, Azure, IBM, they also provide trial versions. You can go and do some hands-on. And then there is a 8box. Most of them could be Docker based, but some may have like a GitHub code, or you might need a Docker Hub license software for. So with this, I will hand it over to Suman to show some practical example of using FHIR.
Yeah. When you get this, we have given this link to all of this. There are almost like 100 FHIR servers available. Okay. So, but yeah, some of the popular ones we have given the links if you want to do your get your hands dirty and try on after this. Suman, over to you. Yeah. If you're speaking, we can't hear you, Suman. We still can't hear you. Meanwhile, till Suman comes on, Suman, you may want to log off and log in again. That helps. Any questions on what? Yeah, now you are. Let me ask, any questions? Yeah, any doubts from anyone or any additions, especially people who have been working in FHIR projects? Okay, looks like no. Someone, over to you.
Thanks, Kapil. Let me share my screen. I hope now the screen is visible to all of you.
Yes.
Okay. So if somebody, first I'll talk about the installation part. So how we can install Happy Server. So for installing Happy Server locally, we have these are the steps we have. For Happy Server, this is the one thing we need is Docker installed. This is a license-based software. So for this, definitely the approval is needed. So today's session, I will be showing the Happy Server, a free public server, which is currently available freely. You guys can also test and check the Happy Server, which I have already mentioned in the chat. So for this, we have already given the Docker. See, we have to pull the Docker image, and then in git bash or any bash, this is a bash command which we have to put and run it. And then next we have to run the Happy Server container. And then next we would be having this local host URL. So currently I will be showing the Happy FHIR server, which is available locally, which is available on free basis. So let me go back to my screen where I can show it. You can search it on Google, and then you can. I'll anyways provide the links. Okay. So here are the two commands, which once you have the Docker ready, then you can run it, and then you would be having this URL, which is for your FHIR server. But currently, I'll be using the public one, which is this one. This is the base FHIR server, FHIR base URL. So I'll again go back to my slide. So next. So I'll be showing today in this call all the crude operations, what we can perform with the resource. So let me give you an example for a resource. Suppose a resource is Elizabeth. Let me show you one bundle and resource. Okay. So there is one resource I am showing on the screen. I think this has already been covered. Karthik has already shown how the JSON look like. So again, I'm showing with a simple example so that everyone can understand. So this is the patient resource. If you see this in this resource, it is having only one resource type. So this is an individual resource. It doesn't have any other resource in this. So it is called resource. And if suppose you think like a Elizabeth, a lady who visited a clinic for his diabetes checkup, and then she met with the doctor and got her vitals checked, and then she went back to home on the same day. So with this data, I have created this JSON. If you see here, her name, details, gender, everything is there. So this is an individual resource. So it has only patient related data. But now if I talk about the bundle, what is bundle? Bundle is like each thing, whatever I said, that been recorded as the bundle. Bundle itself is a resource type. If you could see here, bundle itself is a resource type. If you see the count, it is 21. So it is like recording whatever patient has done. So Elizabeth, she visited the clinic. So her names and details are mentioned here. So next resources are practitioner. You see practitioner. So who did the checkup for her? So it's the doctor's name, James Brown. But next, if you see what which hospital she went for. So this is the hospital details that comes under the organization resource. So one by one, all the resources are added in the bundle. So this is called the bundle, which is the group of all the resource types. It is not a single individual resource. This is a resource type. And then I can also show the condition. So she came for the condition called diabetes. So it's a 1 day, I can say it's a outpatient consultation. So if you see, that is also mentioned. Where is the encounter? Yeah, this is the encounter part. So she came for 1 day consultation. That's why the code is ABM. So these things of details bundle is having the entire detail about the patient. It has in this bundle. So now I'll just show how we can post this bundle, because the Elizabeth, who is the patient, had an outpatient consultation and the checkup at the clinic is done and the visit is completed. Now the record should be recorded in the system. Then how it would be happening? So let me go back to the postman. So this is the postman screen, what I'm currently showing you all. So in this, I'll just take this bundle, repasting here. So it is just I'm taking the new request. It is a HTTP request, and I'm using the Happy server, which is currently freely available, which I have already sent the link in the in the chat box. Even you can go and check it. And this Postman API tool is like you can install it. There is no need for any admin ID password. You can directly install it, and the Happy server is already available. So you can quickly start with this. So now I have just given the URL here. As you can see, you have to put the URL here. So any Happy server, if you are installing it in your local system, then definitely you have to use this one, this HTTP localhost, this. So as of now, I'm using the this Happy server, which is currently available, which is publicly available. So I'm just putting this URL in the URL section. Now, for as the PPT says, let me go back to the PPT. this operations. I think many of you are already aware of this operations, maybe for in some other fields, like for C, it denotes the create, so post. So now the record which I was talking about, the patient one. So now we have to create a resource in the FHIR server, and I have the entire data with me as a bundle. So we have to load this data to the FHIR server as a new resource. So for that, I need to go to this Postman and post this bundle request. I hope I'm clear till this.
Yeah, yes, you are, Sumit.
Okay. So now, till now, I have that patient's data, whatever she has, as she went to the hospital or clinic, whatever she went for a checkup at the clinic for her diabetes checkup, and then she met the doctor, and her vitals are done. So all the details are mentioned in this bundle. So now we have to post this bundle this to this public FHR happy server public. So now I have just selected this. Here you have a lot of operations which you can perform. So currently, as the crude operation, I need to show you all. I'm just selecting post here. Then in raw, I have given my JSON, and then I'll be clicking on the send button. See, the response is generated. You can, when I hover over this 200, okay, this is a response I'm getting from the happy server. From the backend, from their end, they are just validating it. When I'm sending this post request from their end, they are validating it if the FHIR format is correct, if the layout is correct, everything after validation checks, then they decide to create this resource on their server. So if you hover over this, you can see the resource has responded. So now you can see the response here. Now I will see. I will just check the get operation, how we can perform it. Get call. So for that, I need to get the location of the patient, because this particular bundle has a lot of source resource type, right? As I have already mentioned, it has patient, encounter, then observation, then condition, what condition patient had. So all the resources will be present in the FHR server. Now, since I got the 200 okay response, so now I will check whether it is present or not. To check that, I need to take this location, and I can make the get call. You can try anything. As of now, I am trying with the location. If suppose you know the name of the patient and family, anything we can try with that. Let me show you how we can do it with the family name and given names. I can show the bundle first again. So if you see here, I have the family as Miller and given name is Elizabeth. So if suppose I don't have the ID with me, a location I'm not able to track, but I know the patient. So we can just do a get call and we can find this patient.
Just highlighting, right? So what Suman is showing, actually, every EHRB or Apex or NurseBeam, etc., would be running a FHIR server. Okay. And as a provider, if you are implementing a clinical use case, you'll have to trigger these post put methods on that FHIR server run by that EHR, whichever is supported by that provider. Okay. And similarly, the GET requests, which the payers based on authorization can extract or get the patient information. So in practice, it will be happening systemically. For demo purpose, we are using a Postman here. Yes,
Thanks, Kapil. So as Kapil mentioned, for demo purpose, we are using this Postman. So don't think it's only Postman. So now you can see the again I've got the response from the server. I just knew this details, and then I wanted to fetch the record, fetch the data about this particular patient. So I can see the search set is showing here, and the total 17 data I found with this name. So this is how we do the search. Next would be the update. Let's suppose we have something to update for the patient or anything. Like suppose as Harita has already mentioned in his slide, that we can have these many number of resources, right? We can have these many numbers of resources. Let me go back to that particular slide. See, so all these resources I was showing in my bundle. As you can see, the practitioner, patient, coverage, observation, and the allergy tolerance. So let me go back to my bundle resource. So if suppose the something we need to update it, so we would be using the put command. So suppose I have, okay, I have this allergy intolerance. So I just want to take the JSON again, and that particular ID we have to put it here. If you want to change the you want to update anything in that particular patient's data, then we have to put this ID in the URL along with the URL, and then we can just change it to something like maybe she has some allergy with the cashew nuts. Then we can just update this. Okay, see, we got the response again from the FHIR that this record has been updated. Like this is a normal, simple example which I'm giving. So how is it actually works with the patient's data or anything. Maybe the provider needs to order some medication. So they can just place the order and send the CDR hooks that I think Harindra has already covered in his previous slide. So for that also we have to create a bundle, and that we have to create a resource that is service request that will send as a service request. So this is the simple example what I'm giving here, just to show how this actually works with the patient's data. That's the reason I just practically explained about the patient. Now if you take the delete option, this is actually self-explanatory. We can just have the URL along with the resource, and if there is any ID, if the ID is already there, then we can take this ID and we can just check, and this is done. We can see the resource is no longer needed and resource is deleted. So this is the crude operation all about. Maybe in future we have other sessions where we can cover more. It's just the simple one so that everybody can understand. I
Yeah.
think
Yeah. Okay. Anything else you have, Suman?
no, no, Kapil. I think this is
Okay.
all about the crude operations.
Yeah, thanks. So team, what's happening is this looks very technical, but it need not be. So another pattern which is happening is you put a AI layer right on top of this. So instead of doing a technical fire query, you can actually search a patient, not just a patient, about some condition, some observation, some encounter which you want to analyze using natural language, and then that AI layer converts this whatever fire resources which it receives back into natural language and show to the end user. Okay. So that's the pattern which is happening across the board. As we discussed, there's significant demand of fire developers in the market and in the industry today, including in emits. We are forming actually a core team around this.